Okay, so it looks like most of you guys are finishing up your multiple choice Monday, so let's start our notes. So, we've been talking about probabilities and the different ways you can calculate them. So we're going to be going over some different probability rules, so different formulas for what we had before. So hopefully you had enough practice with those other ones that you're kind of getting them down. So when we see this symbol here, anybody know what that means? It's a U. Very good. This is union. Oh, that's really tiny. So that's a union. This is used when we see an OR. So if it's A or B, we use this symbol. Okay? It's called a union. Okay, so on the inside, we have our general addition rule. So, to calculate the probability of A or B, we do probability of A plus the probability of B minus the probability of A and B. So this is OR, this is AND. So this is looking at, if you're thinking of a Venn diagram, if it's anywhere in either circle or in the overlap. This is just the overlap part. So when you're looking at this, is always either or both. So it includes A, it includes B, and it includes where both things occur. Unless they specify otherwise. You're always going to have either one or both. So if we're looking at this like a Venn diagram, A here, B here, and this is our overlap. This is the A and B. We want to be careful not to double count the overlap. So if you're adding together all of A and all of B, you've counted that overlap in both. We don't want to do that. That's why we subtracted at the end. We look at all of A, all of B, and then we subtract where we have counted it both to keep from counting it twice. Over here on the disjoint or mutually exclusive, this is where there is no overlap. So that just means events A and B cannot occur together. They intersect. There's nothing where it's in common for both. Something is in A, then it's not in B. If it's in B, then it's not in A. So anytime they tell you that two events are disjoint or are mutually exclusive, you need to picture it that way. They're two totally separate things that cannot happen at the same time. So an example, senior and sophomore. If you're a senior, you can't be a sophomore. If you're a sophomore, you can't be a senior. Those are disjoint. If we have senior and male, these can happen at the same time. We have people in this room that fit that description. They're seniors and they're male. So this would be not disjoint. So if A and B are disjoint, or mutually exclusive, then the probability of A and B is 0. And this is one that they will put on there sometimes just to see if you don't catch the fact that it's disjoint. Okay? So read the wording carefully. If it's disjoint, the probability that both things will happen is 0, because they cannot both happen. Any questions so far? Okay, let's look down at the next section. So this is a given. So we would read this as the probability of A given B. This is what we call a conditional statement. So if they're telling you a conditional probability, this is what they're talking about. So we're given that one thing happened, we want to know what's the probability of the other one also occurring. So this probability of A with a line, then B. You want to read as probability of A given B. This, like I say, is a conditional statement. Which means we place a condition that must be met first. So, for example, if you see a phrase like that of this group, that's going to tell you it's a conditional. You could also see if the student is a senior, then what is the probability they are female, or something like that. What is the probability they park on campus? So that is this, if something happens, that's the conditional part. So they're saying we're only looking at this group, and then we want to know some probability within that group. That tells you it's a conditional probability. So here we're looking at a specific subset of data. So this is where if you're looking at a contingency table, you're isolating one row or one column, and you're looking at the total for that column or the total for that row, and finding one of the cells over that total. Okay, so that's how you know when to use this. Now we're going to talk about what's the rule. So the conditional rule, so our formula for this calculation, probability of A given B is the probability of A and B over the probability of B. And we have to know probability of B is not 0 because we know B happened. Okay, we're saying if B has already occurred, what's the probability of A? So we know this cannot be 0, so we're not dividing by 0. So that's kind of the thing you need to be able to point out. If we reverse this, probability of B given A, then we do the probability of A and B over probability of A. And then we would know the probability of A is not 0 because it has already occurred. So this is a note. The denominator is the condition or the subset of interest. In other words, whatever is here goes to the denominator. So the given part, that's your denominator, and then the and part is probably both things happening, so this is that overlap part is on top. Questions so far? Okay, so let's look at this last part down here at the bottom. So this one, as we talked about before, this is our AND. This is called the intersection. So if it's a U union, if it looks like an N intersection, you can kind of remember it that way. So this is where both things are occurring. This is that overlap part. Okay, So to get to this general rule, this is really using this up here. If you notice the numerator on both of these is what we're looking for in this bottom part. It's the A and B. So if we multiply both sides by this denominator, we get our general multiplication rule. So that just says the probability of A and B is the probability of A times probability of B given A. Or we could say it's the probability of B times probability of A given B. So it just depends on which one they tell you the conditional for. Whichever one you have here is going to tell you which one to multiply by. This is just a rewriting. So if you look on your blue sheets, you'll see under the probability, we got this rule. That was that first rule at the top. That was our general addition rule. That's on there. And then this conditional rule is on there, but that's the only one they give you. They don't give you B given A and A given B. They need you to know that whatever is here at the end is what goes in the denominator. Okay, they expect you to know that. They do not give you this general multiplication rule because it's just taking the denominator and multiplying it to the other side. So they expect you to know how to use this to find the value of the numerator. Okay? So when you're looking at these first two can do everything that we've done on this foldable, but sometimes you're going to have to manipulate the equation a little bit. Okay? So these will be provided to you, but not in this form. Okay? So you need to know that's where you're going to find it on your formula sheet. So, note. You can use the general addition rule. To find the probability of A and B as well. Use the formula for which you have the other information. Then solve for the probability of A and B.